based on one of the application of derivative, that is rate of change. Let's do a question. Our question is, equation of motion of a particle is s equals to t cube minus 60 square plus 8t minus 4. Find the velocity and acceleration of the moving particle at t equals to 3 seconds. Here we have to calculate velocity and acceleration at t equals to 3 seconds. Let's do solution. Here we have given s equals to t cube minus 60 square plus 8t minus 4. This equation is for displacement, that is s is displacement here. Now we have to calculate velocity. What is velocity here? That is change in displacement upon change in time. So here we have to calculate derivative of s with respect to time t. That is, we have to find d by dt of s, and what is s here? T cube minus 60 square plus 8t minus 4. So let's find derivative of s. D by dt of s is d by dt of, put equation of s here, that is t cube minus 60 square plus 80 minus 4, which is equals to d by dt of t cube minus, we take constant outside the derivative, 6 into d by dt of t square plus 8 into d by dt of t. Here there is no variable, so we will take derivative of 4 minus d by dt of 4. Now we know that d by dx of x to the power n equals to n into, this n comes here, into x to the power n minus 1. We use this formula here. So derivative of t cube would be 3 into t to the power 3 minus 1 minus 6 into derivative of t square would be 2 into t to the power 2 minus 1 plus 8 into derivative of t would be, here power of t is 1. So 1 into t to the power 1 minus 1 minus, here 4 is constant and we know that derivative of constant term is 0. So here d by dt of 4 is 0. Next 3 into t to the power 3 minus 1 is t to the power 2 minus 6 into 2 into t to the power 2 minus 1, that is 1 plus 8 into t to the power 1 minus 1 is t to the power 0, which is equals to 3t square minus 6 into 2 is 12, 12t plus 8 into 1. We know that any number with power 0 is 1. Since t to the power 0 is 1, so finally we get equation of velocity, that is 3t square minus 12t plus 8. So here we get velocity v, which is equals to 3t square minus 12t plus 8. Now let's do for the acceleration. We know that acceleration is nothing but rate of change in velocity, that is derivative of velocity with respect to time t. So we know that acceleration is dv upon dt. So to calculate acceleration, we have to find derivative of v with respect to time t, that is d by dt of v. Now we have calculated v. What is v here? 3t square minus 12t plus 8, which is d by dt of 3 into d by dt of t square minus 12 into d by dt of t plus d by dt of 8, which is equals to 3 into, what is derivative of t square here? 2 into t to the power 2 minus 1, that is 1, minus 12 into derivative of t would be t to the power 1 minus 1, that is t to the power 0, plus here 8 is constant and we know that derivative of constant is 0. So derivative of 8 would be 0, which is equals to 3 into 2, 60 minus 12 into t to the power 0 is 1, which is equals to 60 minus 12. So here we get equation of acceleration, which is 60 minus 12. So we have calculated equation of velocity and equation of acceleration. Now we have to calculate velocity and acceleration at t equals to 3 seconds. So at t equals to 3 seconds, we have to find velocity here. Here we calculate velocity as 3t square minus 12t plus 8. So we put t equals to 3 here, that is 3t square equals to 3 into 3 square, minus 12t is minus 12 into 3 and plus 8 as it is. Now 3 square is 9 and 3 into 9 is 27. So here it is 27, 12 3s are 36 and 8 as it is. Now 27 plus 8 is 35 and 35 minus 36 is minus 1. So here you get velocity v equals to minus 1 centimeter per second. Now we get value of v in negative, that means the particle's net displacement is in negative direction. Now let's see for acceleration. Here we have equation of acceleration as 60 minus 12. We put t equals to 3 here. So here we get 6 into 3 minus 12, that is 6 3s are 18 minus 12 and 18 minus 12 is 6. So here we get acceleration a equals to 6 centimeter per second square. So at t equals to 3 seconds, we get v equals to minus 1 centimeter per second and a equals to 6 centimeter per second square. Thank you.